All right, let's get straight to it. Today, we're defining the AI terms that are actually going to matter for architects. Forget the hype. These are the concepts you'll be building with in 2026.
So let's just rip the Band-Aid off right away. The age of simply writing prompts, it's over. That was the tutorial level. The main quest, the real architectural challenge for us, is building systems that can think and act on their own. The age of the automation architect has officially begun.
So here's how we're going to break this down. First, we'll lay the foundation, the core building blocks of these agents. Then, we'll get real about what it takes to run this stuff in production. After that, we'll zoom out to look at the big picture of governance. And we'll wrap up with what I think is the most important part, the critical choices you need to make for your career. Okay, first things first. We have to start with the fundamentals. Think of these as the absolute non-negotiables, the core patterns that dictate how these modern AI agents perceive, reason, and act in the world.
First up, the Agentic Loop. This is the heartbeat of any autonomous system. It's a simple, powerful cycle. Perceive, plan, act, and then, and this is the key part, reflect. A perfect example? A test suite that doesn't just fail, it sees the UI break, figures out a code fix, applies it, and then reruns the test to see if it worked, all on its own. Now the how is where it gets really interesting. That's the ReAct pattern. It stands for reason and act, and it's a huge leap over basic chain of thought. Why? Because it lets the model stop mid-thought, go use an external tool, like query a database, and then bring that result back into its reasoning process. It's a game changer.
So, with these agents running wild, how do you make sure their work is actually any good? Two crucial techniques here. The first is self-refinement. Basically, the model acts as its own harshest critic. It generates a draft, then runs it through a critique loop to check for quality before calling it done. Think of it as building a system that can proofread itself. The second one, structured generation, is, well, it's absolutely essential for any production environment. You're forcing the model's output to fit a strict schema, like JSON. This means you can plug its output directly into another API without ever worrying about parsing errors. It just works. Okay, now we're getting into the really cool stuff. Agentic RAG. This is not your standard retrieval augmented generation. In a normal RAG system, it's just find a doc, then answer. With Agentic RAG, the agent thinks about what it needs to know. It might decide to search 3 different databases, read a news report, and then put it all together. It's an active, autonomous research process. And then, recursive latent state. Look, this is a peek into what comes after the transformer architecture. It's a wild idea where a model literally feeds a summary of its own thought process back into itself as input. The result, these incredibly deep, hyper-efficient models that can solve complex logic puzzles using way fewer parameters. Keep your eye on this one. All right, we've got the theory down, but theory is easy. Now let's talk about the messy reality of making this stuff work in production, at scale. This is where the real architectural headaches begin. The first big problem you're going to hit is context rot. As an agent works on a long task, its memory, that context window, just gets filled up with junk and irrelevant details from hours ago. Performance plummets. The architectural fix is twofold. First, token pruning, which just cleans out redundant info. But the more elegant solution is context folding. The agent can essentially say, okay, I need to solve this side quest, open a temporary context, do its work, and then collapse that entire history down to a single summary before returning to the main task. It keeps the primary context clean and on point. And then there's the pain point we all feel. Inference famine. There's just not enough high-end GPU power to go around. This means long queues and insane costs. The key architectural fix here is speculative decoding. It's brilliant. You use a cheap, fast draft model to quickly generate a bunch of possible next words. Then, your big, expensive model swoops in and validates that whole chunk in one go, instead of generating word by word. And this isn't just theory. The impact is significant. You can see from the data here that this technique boosts throughput by over 35% compared to strong baselines in long context workloads. By choosing the right draft model, you can dramatically reduce the cost per token and increase overall system throughput, directly addressing the inference famine. 2 more crucial operational points. Inference quantization is all about running models on cheaper hardware. By dropping the numerical precision down to something like 4-bit integers, you can deploy powerful agents on edge devices without needing a high-end GPU farm. And finally, a silent killer, vector embedding drift. When you update your embedding model or your data changes, your entire vector index can become semantically obsolete. As an architect, you must have a reindexing and governance strategy. It is not optional. Now let's elevate our thinking.
Once you have dozens or even hundreds of specialized agents running in an enterprise, how do you manage, secure, and orchestrate them? This is the domain of strategic governance.
Two pillar concepts here. First, the Model Context Protocol, or MCP. Seriously, just think of this as TCP/IP, but for agents. It's an open standard that lets any agent, regardless of the model, discover and use any tool that speaks the protocol. This is the key to building truly interoperable systems. Building on that, we have the Agent Lake architecture. This is your corporate mission control for all of your agents. It's a vendor-agnostic platform to monitor, manage, and orchestrate your entire fleet of bots from one place.
And how do we govern what these agents do? That's where constitutional alignment comes in. It's a powerful safety pattern where you provide the agent with a set of principles, a constitution, that it must use to self-critique its own actions. This is how you enforce complex business rules, like data handling policies, inside an autonomous system. Finally, let's talk about the output. Synthetically Generated Information, or SGI, isn't just raw model output. It's high-value data that has been curated and fact-checked by another AI system for precision. This is how you can create things like automated technical training that maintains perfect engineering accuracy. So, we've covered a lot of ground: the core building blocks, the operational realities, and the strategic oversight. Now for the most important part of this entire briefing. If you only focus on 3 things for your career between now and 2026, these are them. Let's be direct. Number 1, agentic RAG. You must master the shift from building simple retrieval pipelines to architecting agents that are intelligent knowledge workers. 2, Model Context Protocol. MCP is the language of interoperability. If you're building multi-agent systems, you will be using it. It is non-negotiable. And number 3, recursive latent state. This is your future-proofing. While everyone else is focused on scaling today's transformers, understanding this is your key to designing the next generation of hyper-efficient models. And that leaves us with one final thought. As these agentic systems become more and more capable of architecting their own solutions to problems, what is the role of the human architect in 2030? That is the question we should all be thinking about. Thank you